Hello, this is Dr. Hanaa Assil, and these are questions and answers on Chapter 1 of Unit 1 in the AS Edexcel Chemistry. So this chapter was talking about atomic structure and electron configuration. Let us take a look at some questions and try and answer them. So the first question that we have says, a sample of potassium is known to consist of isotopes with mass numbers 39 and 41. For each isotope, complete the table below to show the numbers of protons, neutrons, and electrons. So this should be easy. First of all, if we want to get number of protons, neutrons, electrons, the first thing we do is go back to the periodic table and look for, we're talking about what? We're talking about potassium. Then what do we need? We need the atomic number of potassium, and you should know that the atomic number is the smaller number. So potassium has atomic number 19. That means the number of protons is 19 in all isotopes. So if we're talking about different isotopes of potassium, both of them have 19 protons. The number of neutrons will depend on the mass number. So the mass number of that first isotope, he says, is 39. You subtract 39 minus 19. That means we have 20 neutrons. Remember, to get the number of neutrons, you subtract mass number minus atomic number. 41 minus 19, that means that isotope has 22 neutrons. Now, what is the number of electrons? You should know. This is an atom. So the number of electrons is the same as the number of protons. So the number of electrons in both isotopes is 19. Explain the meaning of the term isotope using information from the table. Now, what was the table? This was the table that gave the number of protons, neutrons, and electrons. How do we define the term isotope? You should know that isotopes are atoms of the same element. So getting information from the table, we were talking about these are atoms of potassium. Having the same what? Having the same number of protons, so both of them have 19 protons, but different number of neutrons, so they have, one of them has 20, the other has 22. That is why we call these two isotopes of potassium. Okay, complete the electronic configuration of a nickel atom using the SPD notation. Remember, in the O level, when we were filling out electron configurations, we were writing it 2, 8, 8, and so on. We said the first energy level takes 2 electrons, second energy level takes 8, and so on. But now we're going to use the SPD notation, and that means we're going to use the different sub-levels in each energy level. Now, the first thing we need to do is look at the periodic table to find out how many electrons in nickel. So in nickel, we have atomic number 28. That means we're trying to distribute 28 electrons. Now, how are we going to distribute it? We're going to distribute it in the 1s, then 2s and 2p, then 3s, and so on. The first energy level has 1 orbital, so it takes 2 electrons. And remember that when we're putting 2 electrons into the same orbital, they have opposite spins. So this is indicated by an arrow going up and an arrow going down. So we start filling from the lowest energy level, that's the 1s. Now we go into the second energy level, and the second energy level is divided into 2 sub-levels. The 2s can take 2 electrons. I still have some more. I put into the 2p, and the 2p has 3 orbitals. Each orbital can take 2 electrons, so I can put a maximum of 6 electrons in the 2p. Now, that means I have filled in so far, I have filled in 10 electrons. I still have more. Remember, we said we have 28 electrons. So I go to the next energy level. The next energy level is the third energy level. This has 3s. 3p, and 3d. So we start with the 3s, we put 2 electrons into the 3s. And then we still have some more, we put the electrons into the 3p. We still have some more, we need to fill the 4s before the 3d, because they found that the 4s has a slightly lower energy than the 3d. So when we're filling electrons, are you paying attention? We go 1s, and then 2s, 2p, and then 3s, 3p, and then 4s, and then I'm left with how many electrons? Now I have put in 20 electrons, and that means I'm left with 8. I need to put the 8 into the 3d. Now the 3d can take up to 10. But when we fill electrons, we need to fill 1, 1, 1 into each energy level, and then I start to pair them. And that means that it will be distributed like this. So I filled 1 into each orbital, and then I still had 3 more, so I put them into the orbital so that they are paired in 3 of the orbitals, but the other 2 are unpaired electrons. So when the electrons stand on their own, they're pointing, the arrow is pointing up to show the indication that the electron is standing alone. This is called an unpaired electron. So this 3d has 2 unpaired electrons. Okay, this is how we draw it. But if we're trying to write them, we said, how many electrons did we put in the 1s? We put 1s2, so we write it 1s2. And then, after that, we put 2 electrons in the 2s. So the 2s has 2 electrons. The 2p has 6 electrons. This is how we indicate it. The 3s has 2 electrons. 3p, 6. 4s, 2. 3d, 8. So this is the electron configuration of nickel. Okay, complete the electronic configuration for a bromine atom using the SPD notation. Okay, where is the bromine atom? Remember, bromine has 35 electrons. Now, again, how do we distribute electrons? It's 1s, 2s, 2p, 3s, 3p, 4s, 3d. So if I'm distributing the 35 electrons of bromine, 1s2, 2s2, 2p6, that's 10 of them. 3s2, 3p6, 4s2, that's the other 10. 3d10, so that's 30. I'm left with 5. I put them into the 4p. So if we're writing the full electronic configuration, it's 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, 3d10, 4p5. But he's writing argon at the beginning. What does he mean? He means I can write this in a shortened form. You remember that argon has, from the periodic table again, it has 18 electrons. So instead of saying 1s2, 2s2, 2p6, that is 10, 3s2, 3p6, that's 18. So instead of writing all of this, I just write argon to indicate that these are 18 electrons, and then I continue. So after the 18 electrons, I have 4s2, 3d10, 4p5. So this is a sort of shortened form of writing the electronic configuration. Okay. What if he's saying complete the table to show the numbers of subatomic particles in a bromine atom and a bromide ion? So he's giving me mass numbers for each of these, but I need to go back to the periodic table again to find the atomic number. So bromine has atomic number 35. So both of them anyway would have 35 protons. We don't care about anything else. But when we come to the neutrons, we need to look at the mass number he's giving me. So if it is 79, then 79 minus 35 will be 44. The other isotope is 81, so that is 81 minus 35, so that is 46. Now, what about the number of electrons? Now, if it is an atom, the first one in the table is an atom. So the number of electrons is the same as the number of protons. But the second one has Br minus. It's an ion. And when it is minus, what does that mean? It means it has gained an extra electron. So instead of having 35 electrons, it now has 36 electrons. Okay, let's take a look at the periodic table. Remember, we divided the periodic table into blocks. We said the group 1 and group 2 make up what we call the S block. That means if you sit down and write the electron configuration, you end up with an S. So everything in group 1 will end up with S1. Everything in group 2 will end up with S2. So we call that the S block. Now the transition metals are in the D block. That is because if you sit down and do the electron configuration of each one, it will always end in D something. D1, D2, D3, and so on. The P block means that all the electrons in all the atoms in that area of the periodic table, if you sit down and do the electron configuration, it will always end up in P. And then we have the F block, which are the lanthanides and actinides at the bottom of the periodic table. So these are the blocks. Now, what is the question? The question says which elements are in the S block. So where is the S block? We said the S block is group 1 and group 2. So that is the R and U that he has up there. Here he's saying which element has 4 occupied shells with 6 electrons in its outermost shell. Again, remember when we have the periodic table, we said we have group 1 has 1 electron in its outermost shell. Group 2 has 2 electrons in its outermost shell. 3 has, and so on. So where is the one that has 6 electrons in the outermost shell? That has to be the one in group 6. But also he's saying I want something in 4 shells. There's something that has 4 shells. And we said the number of the shells is determined by the period. So what we're looking at is something in period 4, so that it has 4 shells. And in group 6, so that it has 6 electrons in its outermost shell. And that is 1. In which pair do the ions have the same electronic configuration? Okay, in which pair do the ions have the same electronic configuration? Let's take a look at our first choice. He mentions R plus and T2 minus. Okay, what is R plus? Can you see where R is? Now, when it forms a positive ion, that means it's going to lose electrons, and that means its electronic configuration will be like the one of helium. But T2 minus means T will gain 2 electrons, so it will be like neon. That means they don't have the same electronic configuration. What about T2 minus and Y2 minus? Where is T2 minus? We said T gains 2 electrons, it becomes like neon. Now, Y gains 2 electrons, that's not also the same electronic configuration. What about U plus and T2 minus? U plus. So these two have the same electron configuration, so that is actually my answer. Okay. If you look at U2 plus and W minus, no, U2 plus will have an electron configuration like neon, but W will have a different electron configuration. Which species contains 15 protons, 16 neutrons, 18 electrons? Well, what determines what you're looking for is the number of protons. So he is asking for something that has 15 protons. That means you look in the periodic table for something that has atomic number 15. So you'll find that the one that has atomic number 15 is phosphorus. So my answer is A or B. But then he says it has 18 electrons. Now, phosphorus is supposed to have 15 protons and 15 electrons. When we say that it now has 18 electrons, that means it gained 3 extra electrons, and that means now it has 3 negative charges. What is the electron configuration of nitrogen? Again, to look at the electron configuration of nitrogen, we said we look at the periodic table. Nitrogen has atomic number 7. So you're distributing 7 electrons. We said, how do we distribute electrons? You need to fill the 1s first, and then go on to the 2s, and then go on to the 2p. And when we go to the 2p, the 2p has 3 orbitals of the same energy. You need to put 1, 1, 1 into each orbital before you start pairing. So which of these is the correct distribution? You should realize that D is the correct distribution. I have to fill the 1s first, so it's not A. And then I need to fill the 2s before I go on to the 2p, so B is wrong. And in C, when we have 3 electrons that we're trying to distribute in the 2p, you need to put 1 into each orbital before I start to pair. What are the maximum numbers of electrons in a 2p orbital and in the 3rd quantum shell? Okay, please be careful. Is he asking about number of electrons in an orbital or in a shell? Well, the first part says 2p orbital. So if I'm trying to distribute electrons, for example, for iron, we know that the 2p can take up to 6, but the 2p actually has 3 orbitals. Each orbital can take only 2. So he's asking for how many electrons in a 2p orbital. I can put only 2 in any orbital. So C and D are wrong. And then he's asking how many electrons in the 3rd shell. We said in the 3rd shell, we have 3s, 3p, and 3d. And we said the 3s takes up to 2, 3p can take a maximum of 6, and 3d can take up to 10. So that means 10 plus 6, 8, that is 18 electrons. So remember that the 2p orbital can take only 2. But the 3rd shell can take a total of 18 electrons. Okay? Identify the atom with 2 unpaired electrons in its lowest energy state, ground state. Remember that lowest energy state or ground state means it's an atom. Okay? Identify the atom with 2 unpaired electrons. So let's write the electron configuration for each of these. Now, beryllium has 4 electrons when you look at the periodic table, and this is how they're distributed, 2 in the 1s and 2 in the 2p. So actually, it doesn't have any unpaired electrons. Remember, when I have arrow up and down, these are paired. If I have an arrow, only one arrow in an orbital, we write it pointing up, and this is called an unpaired electron. So actually, beryllium doesn't have any unpaired electron. What about carbon? Carbon has a total of 6 electrons. So we put 2 into the 1s, 2 into the 2s, and I'm left with 2. I need to put 1 into each orbital before I start pairing. So this is how we write it. And that means that carbon has 2 unpaired electrons. So that's actually my answer. If we look at chlorine, and chlorine has 17, so that is 1s2, 2s2, 2p6, 3s2. It has only 1 unpaired electron in the 3p. Calcium does not have any unpaired electrons, so my answer is carbon, which is B. Complete the electronic configuration for aluminium. What is the electronic configuration for aluminium? We said aluminium has 13 electrons. So how do we distribute them? We put 2 into the 1s, 2s2, 2p6, 3s2, and I'm left with only 1, so that goes into the 3p. So this is my electron configuration, and this is how we write it. In which block of the periodic table is platinum? Well, I look in the periodic table. Where is platinum? Platinum is actually a transition metal. Remember, we said the transition metals are what? They are in the D block. Which row in the table shows the number of protons, neutrons, and electrons in a fluoride ion? That's easy. Fluorine has atomic number 9. That means it has 9 protons. So A is wrong. Now, how many neutrons? 19 minus 9 is 10. So my answer is C or D. Now, he's saying what? We're talking about the fluoride ion. That means fluorine with an extra electron. So instead of having 9, it has 10 electrons. So that's our answer. In which block of the periodic table is strontium? Where is strontium in the periodic table? Well, it's in group 2. And we said group 1 and 2 belong to which block? The S block. Which of the following is isoelectronic with the chloride ion? Remember, the word isoelectronic means it has the same number of electrons. So if I look at chlorine, chlorine has 17 electrons. Now, if it is a chloride ion, it now has 18. So 18 is the same as which of these? You'll find that 18 is the same as argon. All the others do not have 18 electrons. Complete the electronic configuration of phosphorus using electrons in boxes notation. So here he's telling me to draw the electrons and write the symbols for the subshells on the dotted lines. So the first one is the 1s, and he put 2. Now, how many electrons am I distributing? I look at the periodic table. Phosphorus has atomic number 15, so I'm distributing 15 electrons. Again, how do we distribute them? 2 in the 1s, 2 in the 2s, and then I fill the 2p. So now I have a total of 10. Then I need to go to the 3s. The 3s takes 2. How many am I left with? I'm left with only 3. That goes into the 3p. Again, when we're filling the 3p, we put 1 electron to each orbital before we start pairing. Which one of the following elements undergoes the change in electronic configuration shown when it forms the stated ion? Well, he's starting with an atom that has 1s2, 2s2, 2p6, 3s2, 3p3. That is a total of how many electrons? That's a total of 15 electrons. So we're looking for something that has atomic number 15. Or you could just look at the last energy level. We have 3p3. Remember that the last orbitals or sublevels, if they end in p1, that is in group 3. p2, that's in group 4, and so on. That is the p block. So if I'm looking for something that ends in the p3, that means I am looking for something in group 5. Because if you distribute it, then it will end up with something p3. Now, you have first energy level, second energy level, third energy level. That means you're looking for something in period 3. And you're looking for something that has a total of 15 electrons anyway. So in all cases, what we're looking for is the phosphorus atom. When it gains 3 electrons, it becomes 3p6. So that is the answer to what we're looking for. Okay? So when you're looking for something from its electron distribution, either you add up all the number of electrons of the atom, that gives you the atomic number, or you look at the last sub-level, it is a p3, that means it's in group 5, because that part is the p block. And of course, the period indicates the number of the shell. So anything that ends with 3p3 will be in period 3, group 5. Okay? In which order do the electrons fill the orbitals of an atom? We said when we're filling the electrons, what is the order of the orbitals that we fill? We said we need to fill what? We need to fill the 1s first, and then the 2s, and then the 2p, and then 3s, and then the 3p before the 4s, and then 3p, and then 4s, and then 3d. So the 4s is filled before the 3d, and then we can go up to the 4p. So this is my correct arrangement. 1s, 2s, 2p, 3s, 3p, 4s, 3d, and then 4p. Complete the table below. What is the relative mass of proton, neutron, and electron? You should know that the mass of a proton is regarded as 1. The neutron is given a mass of 1, and relative to that, the electron would have a mass of 1 over 1840, which is a very, very, very small mass compared to that of proton and neutron. Now, what is the relative charge of a proton? You have to remember, a proton has a charge of +1. A neutron is neutral. It has no charge, or we say its charge is 0. An electron has a charge of -1. Then he says a particle with a single positive charge and electron configuration 1s2, 2s2, 2p6. So positive charge, that means he's looking at a cation. Something with a single positive charge, that means from its electrons we have removed 1 electron. So when we say that the electron configuration of the ion is 1s2, 2s2, 2p6, that means I'm looking for something with 1 extra electron. So instead of 10, I'm looking for 11. That is my answer. So actually, sodium ion is the one that will form a single positive charge, because we said it loses 1 electron. It's in group 1. It will end with a 3s1. We lose it, so it has 1s2, 2s2, 2p6. The others will not give a single positive charge. Actually, fluorine and the oxide ion are negative, so that's not my answer. And potassium will give a single positive charge, but it will not have electron configuration 1s2, 2s2, 2p6. If it loses 1 electron, it has 18 electrons, not 10. So my answer here is a sodium ion. In which of the following electronic configurations are only 2 of the electrons unpaired? So the question is, which of these has 2 unpaired electrons? Again, what is A? A is 1s2, 2s2. So that is only 2 paired electrons in the 1s and paired electrons in the 2s. It doesn't have any unpaired. In B, if you distribute what he has there, the 2p3 has to have 1 electron to each orbital, so I actually have 3 unpaired electrons. In C, we have 2p4. In the 2p4, we said we distribute 1 electron to 1 orbital, and then we start to pair. So this is the one that has 2 unpaired electrons. The last one is 2p5. It has only 1 unpaired electron. Remember, unpaired means it is standing alone in the orbital, and we denote it by an arrow pointing up. An ion X- contains 36 electrons. In which block of the periodic table would the element be found? Okay, X- means it is something that has gained an electron, so actually it should have originally, instead of 36, it should have 35 electrons. So we're looking in the periodic table for something that has atomic number 35. Of course, that is bromine. Now he's asking in which block. Remember that the group 1 and 2 are S block. Transition metals are D block. The non-metals groups 13 to 18 or group 3 to 8 are P block. So the bromine, which is in group 7, is a P in the P block. Which of the following species contains the same number of electrons as neutrons? So you can sit down and calculate the number of electrons and number of neutrons for each of these. Number of electrons in the first choice is 5. The number of neutrons is the difference, 11 minus 5, that is 6. So that these are not the same. He wants something that has same number of electrons as neutrons. So Na plus means it has lost one of its electrons, so now it has 10, and the number of neutrons is 23 minus 11. Again, that's not my answer. Magnesium 2 plus, magnesium originally had 12, it lost 2 of them, so that is 10. Number of neutrons is 24 minus 12. Again, that's not my answer. Now, the last one is our answer, since it has originally 9 electrons, but this is F minus, so it now has an extra electron, so they are 10. 19 minus 9 also gives 10 neutrons, so that is our answer. Which of the following diagrams represents the electrons in the ground state of a boron atom? So we're trying to distribute electrons in a boron atom. I look at the periodic table for the atomic number of boron, that's 5. So we're distributing 5 electrons. How do we distribute 5 electrons? We fill the 1s. So B and D are wrong. And then we need to fill the 2s. So my answer is A. I'm left with 1 electron. So that is the one that goes alone into one of the p orbitals. The number of unpaired electrons in a nitrogen atom in its ground state is what? Now, to determine the number of unpaired electrons, I need to distribute the electrons. So, if we distribute the electrons, this gives how many unpaired electrons? We said I have 2 in the 1s, 2 in the 2s, I have a total of 7. So, I'm left with 3 for the 2p. They go 1 into each orbital. That means I have 3 unpaired electrons. An atom of silicon has a mass number of 29. Complete the table to show the number of each of the particles. Well, silicon, you look at the periodic table, it has an atomic number of 14. So that means I have 14 protons, 14 electrons, and he's talking about what? Remember, the mass number in the periodic table is 28. But he's not talking about that. He's talking about silicon 29. So please use the one he gives you. So it is actually 29 minus 14. So that gives you 50. Complete the electron configuration of silicon. Silicon, we have 14 electrons. How do we distribute them? You remember? 1s2, 2s2, 2p6, that's 10 of them. I'm left with 4, I put 2 into the 3s, and I'm left with only 2 that go into the 3p, and this is how we write it. Which pair of ions is isoelectronic? Again, the word isoelectronic means they have the same number of electrons. So which of these have the same number of electrons? If I have calcium 2 plus, calcium originally has 20. 2 plus means it lost 2 of them, so that's 18. And oxygen 2 minus has the same electron configuration as neon because it gains 2 electrons and it becomes 10. So these are not isoelectronic. Now, sodium and oxygen. Where is sodium? Sodium is 11. It loses 1 electron. It has the same configuration as neon. It has 10 electrons. Oxygen will gain 2 electrons in order to form O2 minus. So this is the one that we are looking for. These are the ones that are isoelectronic. The others you will find are not the same number of electrons. Remember, isoelectronic means when they form these atoms or ions, they have the same number of electrons. Complete the table to show the number of protons and neutrons in these two isotopes. So he gives me two isotopes of iodine. What is the number of protons? Remember that he gives me the atomic number is 53. So the number of protons in both of them is 53. Number of neutrons is the mass number he gives me minus 53. Then he says when iodine 131 decays, one of its neutrons emits an electron and forms a proton. So that means he's talking about iodine, and he's saying the iodine will do some sort of reaction. This is radioactivity, and it will form a new proton. So instead of having, iodine has what? Has 53 protons. Instead of having 53 protons, it will have an extra proton, so that's 54. He's saying identify the new element formed. The one that has 54 protons is xenon. Complete the electron configuration for arsenic and selenium. So let's see. Arsenic has 33 electrons. Remember we said when he puts argon between brackets, that means you have already distributed the first 18 electrons. So 18 plus 3d10, that's 28. 28 from the 33, I'm going to put 2 of them into the 4s and the rest go into the 4p. If there are 3 electrons, they go 1 into each orbital. Selenium has 34, so it's the same distribution. Until we go to the 4p, we need to put 4 electrons into the 4p. That means I'm going to put 1 into each orbital, and then the 4th will be used to pair the first electron. Okay? In atoms, electrons fill up the sublevels in order of increasing energy. Fill in the last 2 boxes in the table below to show the order in which the next 2 sublevels are filled. Remember we said 1s, 2s, 2p, 3s, 3p, 4s, and then 3d, and then 4p. Please remember that. Explain the term orbital. What does the word orbital mean? Remember that an orbital is an area around the nucleus in which there is a high probability of finding an electron. So this is the place where the electron can be found. Draw diagrams below to show the shapes of s orbital and p orbital. You should know that an s orbital is spherical. So the 1s is spherical, the 2s is also spherical but slightly bigger. The 3s is also spherical but bigger, and so on. The p orbitals are all what we call dumbbell shaped. This is called dumbbell shaped. So they can be along the x or along the y or along the z axis, but they are all dumbbell shaped. State the total number of electrons occupying all the p orbitals in one atom of chlorine. Please pay attention to what he is asking for. What does he want? He wants the total number of electrons in all the p orbitals in chlorine. So, first thing, I need to distribute the electrons in chlorine. How many electrons? From the periodic table, there are 17 electrons in chlorine. How are they going to be distributed? 1s2, 2s2, 2p6, 3s2, 3p, 5. And he's saying, what is the total number of electrons occupying the p orbitals? Well, we have 6 in the 2p and 5 in the 3p. 6 plus 5 is 11 electrons in all the p orbitals. And that was the last question. I hope you were able to understand this chapter a little bit better. Thank you. Thank you for listening.